Okay, a couple more exercises I'm just going to look at with you because we talked about these yesterday. The one difference between the chi-square test of association and chi-square test of homogeneity. So, see the this is the one here. Okay, so they give you the data in a two-way table, but all they say is there's 1,509 full-page ads that show a model. So they don't explain how they're how the data was collected. So the first question says, part A says, describe how they would have been collected so that a test for homogeneity is appropriate, right? So a homogeneity test would be, we look at these ads and we take random samples of ads that are for men, ads that were for women, and ads that were for a general audience. We have 3 separate samples. That's where our test for homogeneity would be. If we just take one giant sample, and then after the sample's taken, divvy it up this way and say, okay, look, here's, a total of, let's see, 619 ads that were for men, and then among those, now we're going to divvy them up into the sexual, non-sexual category. That would be your chi-square test of association. That's what they're asking you here in B. Describe how they would have been collected for a test of independence is appropriate. So, that's where, some of those apples we were looking at yesterday were a little tricky because we didn't really know how they collected them, so it's a little bit tough to see which one of those tests it is that we're setting up. Show how each of the numbers 60.94, 424.8, and 12.835 were arrived at. So those are expected counts, and if you remember from yesterday, to get your expected counts, you have to take your, so if I wanted the expected counts, let's see if I can find where those numbers are in here. 60.94. Yeah, I'm not seeing. Oh, there it is. It's in here. 60.94 is right here. 424 and 12.835. So those are my expected counts for those cells. So I would first take my row total, and so if I wanted the expected count for women in the non-sexual category here, I would take the total number of women, okay, which would be 225 plus 351, multiply that by the total number in this row, and then I divide by the total in the table, which I don't have in front of me here. But that's how we get those expected counts. And then, which cell contributes the most to the chi-squared statistic? That's just the one that's going to have the biggest difference between the that chi-squared statistic. You can look at, so I'm going to have 6 chi-squared statistics. I'm going to get a chi-squared statistic. I'm going to get an expected count for this cell, expected count for this cell, expected for this. I'm going to get all the 6 different expected counts cells, and when I compare for each one of those, I'll have 6 different observed minus expected squared divided by expected. And when I look at those 6 components, that's where I find my largest contributor. Now, the reason I want to look at that one, I'll use this example here because your calculator will give you all of those. Okay, so here we have. They want us to make a graph. That's not a big deal. That's just going to be bar graphs. To compare the distributions, we could look at. We could do side-by-side box graphs or bar graphs, or you could do the what's called like a percentage bar graph, where I have the females and I break these down per percentage. So there's 1 bar for female, 1 bar for male, and you can just see, what's the highest percentage among females? Is it grades, popular, or sports, and so on, and the same for the males. So just eyeballing, it looks like the males have a higher interest in sports, while females tend to have a higher interest in popularity. The grades, definitely a difference there, but probably not as huge. So I'm going to go right to the calculator for this one. And like I said, I'm hoping you have the Inspire. That's what I used before. This Inspire with the cost. So I go to Menu, and actually, if I can just get to my home calculating screen, that should work. So I'll just pick my calculator. Yeah, that's what I want. There's one of these screens here. So I'm going to go to Menu, and if I can find this matrix deal here, I am going to create a matrix. Let me just go back and look at that. What's this matrix going to look like? It is 3 rows by 2 columns. So it's 3 rows by 2 columns. We're good to go. Best I can get those numbers in here. We want 130, 117. And 50. And then one more. 30 and 60. Okay. So what I want to do now is store this matrix. I have to give it some kind of a name. So you have on your calculator over here, there should be a store button. Yeah, if I hit Control and the variable key, store it, okay? And I'm just going to call this, call it K for kids because it's about popular kids or something. So that should work. So I press enter. So that matrix is stored as K. So we go Menu. We are doing some statistics as usual. This is a stat test, and it is the chi-square test, okay? It's not goodness of fit. Goodness of fit is the one I did earlier where you have one list. When it's a matrix, it's either chi-squared independence or chi-squared test of homogeneity, but it doesn't differentiate between those two because either way it would be a matrix. So I just tell it my observed matrix, hey, is matrix K. We click OK. Runs the whole test for me, right? Gives me my chi-squared value, my p-value. So I'm going to conclude there's significant evidence of an association between gender and what kids are interested in, right? Grades, sports, popularity. Now notice down here you have expected matrix, compiled matrix, right? So if I wanted to look at that, right, if you press your variables key, so if I want to get those, if I want to look at matrix K, I can click on it and bring it up. But if I want to look at that expected matrix, okay, click on that and press enter, and it shows me these are my expected counts, right? We need those all to be bigger than 5, all right? If I go to variables again and look at this component matrix, right, what does that do? This shows me what had the highest component to it, right? And this is what we sort of eyeballed down here, right? This was sports and popularity, I think, amongst guys and gals, right? Let's see. Yeah, down here, sports amongst the males and the females. Well, that had the highest component. That's where it was the furthest off. That's what contributed the most. So, you know, we make a generic conclusion and say there's significant evidence that there's an association between males and females, but that component matrix, when I look at this, it allows me to go a little bit a step further and say, you know, it looks like the biggest contributor to that is how males and females differ on how they value sports. Okay, so that's pretty much everything that is chi-squared. You know, review, study up, good luck, and, you know, let me know if you need any help with anything else. All right, take care.